sine, cosine, and tangent functions. Now, with tangent, we won't really do as much with the graphing. Those ones will more just be like writing the information about them and such. But when we start translating trig graphs, we'll do a teeny bit with them, but mostly we'll be spending time with sine and cosine because that's a bulk of what you need to be able to do in pre-cal. Now, again, I will reteach it in pre-cal, but I just want you to have the basis for it now, because when I wait and teach it, like I think it was last year, was the first year for pre-cal, and I hadn't been forcing them to graph them, we had to spend a lot of extra time on it in pre-cal that would be better to be spending time reviewing. So if you've seen it before, we don't have to spend as much time on it. Anyways, so starting at number 6 here. These ones say graph the function. Instead, we're just going to be stating the amplitude and period for these problems. So state the amplitude and period. What else can we find when we have a tangent function? Has an abbreviation. Should have been like the last thing under characteristics of tangent.
The asymptote?
Yep.
Don't cross them. Oh.
Find the vertical asymptote. Correct. Don't cross them.
They kept on talking about
Oh, that's what that was.
If tangents
Vertical asymptote.
Yeah.
All right, so
What?
number 6. Y equals 1/5. Oh, not that. I lied. Y equals the sine of 1/5 x. That's not what I was trying to click
Why do
on.
you always have to tell it to stop doing that?
I don't know. I literally went to settings and turned it off and said to stop doing it in settings, and it did nothing. It still continues to do it. I don't understand.
He just doesn't like you.
It's really annoying. Virginia's iPad does the same thing.
So can I
Mine
ask?
has it,
is
but
it-
I can actually get it to turn off.
You just interrupted Daniel.
That's nice.
Yeah.
So in this thing, okay. My question is sine of 1/5 x, is it like 1/5 x is what we're finding the sine of?
Yeah.
Okay, or it's not just 1/5 and then times x, like sine of 1/5 and then x.
No, it's normally, I don't know why they don't. Normally there would be a parentheses around this stuff. I don't know why they don't, but I'm just doing it as the book does it. But yes, technically speaking, it's of 1/5 x.
You just put them up inside.
When we move into the next section, they will be forced to put parentheses because it will make a difference on how it's shifted by whether or not it has. That's why I don't like that they don't in this section, but.
Did you put them up inside?
All right, so the amplitude is always whatever number is in front of the trig function. Now, the thing I'm going to caution you is when we move into the next section, sometimes it'll be something like 3 plus the sine of 1/5 x. It's got to be the number that's directly touching sine.
1.
Okay, so in this case, yes, it's 1. So the amplitude here is just 1. The formula for period is 2 pi over the absolute value of b. So b is 1/5, so this would be 2 pi over 1/5. Now, I only use the absolute values if I'm dealing with a number that's negative, obviously. So what does this end up being equal to?
A fraction and a fraction is
10 pi.
Oh, it's a fraction and a fraction.
Yes, it is.
We've done this before.
Okay, so you find the amplitude by what sine is multiplied by?
Yes, out front. Whatever's directly in front. So in this case, it's just a 1. And it's the absolute value of that. Because, again, what's coming in the next section, if that number is negative, then it's actually reflected, meaning the graph is flipped upside down. So that's why the amplitude is the absolute value. But, again, I only deal with that if I'm actually given a negative number. I don't write that
Is
otherwise.
the period absolute value or the amplitude?
Both.
Okay.
The bottom of this would be the absolute value, and technically this is the absolute value of whatever the number is in front. But I usually just don't think about it that way because I just know amplitude and period have to be positive. So I don't really even think about it. And it's very rare that they give us a b value that's negative.
So
I don't know if I've ever seen one that's negative.
is there an A in this problem?
Amplitude
So
would
it's
be what's
just
in
the
front.
reciprocal.
Because technically what we'll end up with between the next section and now is it'll be y equals a times, I'm just going to say sine of bx. I have to think of what letters that they're going to use. What letters are we using here? Minus h plus k. They use h and k in this book. Books use different letters. Some use c and d, so I have to...
What is it?
So this will be the ultimate form of what's happening. Inside will tell us if we're going left or right. Outside will tell us if we're going up or down. So a lot of times, I think the pre-cal book does C and D. But it doesn't matter what the letters are. It's just what it's set up as.
Okay, so when we're dividing by a fraction, you just multiply by the reciprocal. Okay, cool.
Keep change flip.
Thank you. I'm sorry for asking, but
No. I'd rather you ask now than get the problem wrong later.
Okay, so I
We
have to
might
write that
still
out.
get it wrong.
keep
later.
change flip.
No.
Two pi
Minor
over
details.
one.
KCF.
All right, 10. F of x equals 2/3 times the sine of x.
Change.
This time we have an A.
Yes, we do have an A value. Technically, there's always an A value, but not always one that's visible. So what is the amplitude of this problem?
Absolute value of 2/3,
2/3.
which is 2/3.
And the period,
Period is.
I hate functions.
It's just 1.
2 pi.
2 pi over 1, which would just be, I'm going to write it as that for right now so that we're seeing it written over the B value, but that would just be 2 pi. And in the next section, we'll be talking about how we break the period down into 4 segments. We basically will divide the period by 4 to give us our values that we're counting our x-axis by. Because when it's 2 pi, pretty easy. When it's other things, it's not as easy.
Hello. Is that a Baja Blast?
You're good. Thank you.
You're welcome.
I'm so excited. I haven't been there yet.
Forgot to bring something to stir it with.
Oh, that's fine. I think I have a straw or something. Thank you.
You're
Can I
welcome.
get some slurp juice?
All right. Y equals 2 sine of 8x.
Okay, so the amplitude is 2.
Yep. Amplitude is 2. Period is,
2 pi over 8.
which is,
1/4 pi.
yep, pi over 4.
We're really good at this.
So that means that what the period means is that in this case, every increment of pi over 4, we have gone one full cycle of our graph.
Cycle? What is a cycle of the graph?
And then
So like with sine, it would look like that. That's one full cycle.
Okay.
And then it starts over. It would keep going.
So it would just be
These
like
these
really
graphs
long
just keep going over and over again.
pi.
And like cosine and sine are the same graph, one's just shifted.
Oh.
Like they look the same, it's just they're
Oh yeah. They
shifted
are.
because
Okay.
their starting point is different. And what's probably not talked about in that video, but again, we'll talk about tomorrow, is that if you ever forget where to start a parent function, look at your unit circle.
The parent function is.
The sine of 0 is what?
0.
0. That means it starts at 0. What's the cosine of 0?
0.
0. 1.
1. So it starts at 1.
So
So it's easy to remember where are your asymptotes on tangent, where it's undefined. So think about on your unit circle, where's tangent undefined? Okay?
On the
There is
y-axis.
where I put my asymptotes.
on the y-axis. So you would start on 0, 1.
So that's when x equals 0.
when x equals 0.
So at increments of pi over 2,
Yes.
odd increments of pi over 2. All right, let's see, 18. Finally a cosine one. Here we go. Y equals 3 cosine of pi x. Amplitude is
3.
3. Period is
2 pi over pi, which is 1 pi.
try again. Just 2.
Try again. Whoa, so it works for cosine and and sine.
Yep, cosine and sine are the exact same thing.
What about
Tangent does not have an amplitude because tangent goes on forever. They have an amplitude and or not an amplitude. Said the wrong thing. They have a period and a vertical asymptote. So tangent 1,
22.
f of x, we will also do 22, equals 2 tangent of 4x. So there's no amplitude here, so the number in front, it means something different. It's about how it's extended anyways. So the period of a tangent function is pi over the absolute value of b. So again, this number would have to be positive. So this would just be pi over 4.
Cool.
Now, the vertical asymptotes for this, very similar formula, but it's pi over 2 times the absolute value of b. So this is pi over 2 times 4, which is pi over 8. So at every pi over 8, we have a vertical asymptote for this problem. All right, one more. 22. F of x equals 4 tangent of pi x. So the period would be what?
The period.
2.
No.
1.
Pi over pi, which is 1. Then my vertical asymptote would be what?
It would be pi over 2 pi.
So pi over 2 pi, which just ends up giving me 1/2. So sometimes the pi's stay, sometimes they don't. It just depends on the problem.
Just equals 1.
All right, so your problems, but you can just hold on to these and like turn them in with the next section. So you don't have to do these tonight. It's only 5 problems. You could probably actually finish them in the next 3 minutes that we have of class, but totally up to you. But these can just be on, you can turn in 14.1 and 14.2 as like one assignment. Okay, and for those of you that are wondering, in GradeLink, it doesn't make a difference. As long as you're doing your homework, it doesn't make a difference. So 14.2, like I said, there's no notes as far as a video for you to watch. We will have notes, so I would expect that for the next 2 days we'll be on 14.2. And then we'll be moving into 14.3 and 14.3 does have notes. Now, the other thing I'm going to tell you about 14.3, okay, which you should have these done for Wednesday because we'll be doing this section on Thursday, and if you don't have them, you will be lost.
So it's about to be hard?
It's not hard, but it will be if you don't have the notes done, okay? Because there's a whole bunch of identities you need to have. You will have to memorize those. So I would also start working on that, okay? Because you have to know those. Now, you will have a cheat sheet, but the way the cheat sheet works is we will, the day before the test or the quiz, we will fill out the cheat sheet. Okay? You have to know it. If you have something wrong, I will fix it. If you just don't have it all together, I do not give it to you. Okay? So we do it the day before so that I can check them, especially since this is a bigger class, so that you can have them back to use on the test. Okay? So, anyways, just so that we're aware of that.